Thank you. Meet John. John just wants to rent a car for the weekend. For John, it's simple. Just need to pick the dates, the car class, payment method, and that's it. For the system, it's a little bit more complex. The process spans multiple microservices. Each has its own state. What happens if one of them fails? How do we make sure that the system stays consistent? How do we create an all-or-nothing process when we have multiple microservices with different states? My name is Alon Fliess. I'm the owner and CTO of 𝗦𝗲𝗀𝗀𝗀, a software house. I have lots of experience. I am a Microsoft Regional Director and an MVP, and I recently write this book that you can scan. And if you want to read more about architecture and Saga, you can go and download the book. So, in the left, we have the monolith. This is what we used to have, a simple life, a single database that we can have an atomic transaction and all or nothing baked into the system. But we wanted to have scalability and high availability, and for that we moved to microservices. And now we have the states across multiple services, and we need to somehow make the system consistent. And according to the CAP theorem, when you have partitions, multiple services, you cannot have both availability and consistency. So how do we ensure that we will eventually be consistent? So we need to remember that we no longer have an acid, atomicity, consistency, isolation, and durability. We're now in the field of eventually consistency. We can use patterns like outbox and queues, but this pattern does not guarantee consistency. They just guarantee delivery. And what happens if we don't do that? Our customer needs to call and ask, did I pay? Did I get the car that I reserve, and so on? And we don't want our customer to do that. We want our system to do these calls and to figure out what is the state and to ensure that the state is correct. Enter the Saga pattern. So it's a pattern that orchestrates the flow among multiple microservices. It knows how to call to do the action, how to validate, how to retry, how to compensate in a case of one service or many services that failed. And there are many ways to implement the Saga pattern. We are talking about cloud native, and I think the best platform to create cloud native application is Dapr, distributed application runtime. I don't have the time to go into all the services that Dapr provides, but let me talk about two of them. One of them is the actor model, which provides a full state service, which can go to sleep and come again. And it's great for asynchronous process like Saga. And you can implement Saga using Dapr workflow, even though it's for general workflow, not specifically for Saga, but you can use it to create a workflow. And of course, we need to host the application, and we can locally use Docker Compose, for example, for simplicity. But when we move to Azure, we can use a host application in Azure container apps if the workload is small and simple, or we can go with the full-blown Kubernetes with AKS. And both platforms support Dapr out of the box. Now, in the left, we have the success story. And the success story is just, we have reservation manager, we book the car, we assign the car in the inventory, and we charge the customer. But what happens if billing fails? Now we need to revert our action. So we need to remove the car from, or bring it back to the inventory. And in the booking, we need to write down that this transaction has failed. So it's not like an atomic transaction that we delete everything. It's just a compensation process that we say that this is the output or the outcome of this process. So if we want to use Dapr workflow, we can write our code and in case of a failure, take care of compensation. But this is a cumbersome process because we need to take care about all the details and the retries ourselves. So for that manner, I created another platform which called Saga way. And in Saga way, we use the builder pattern to declare about our Saga. What to do on completion, on success and failure. What are the do operation, a car booking operation. This is the function to call. This is the number of retries. This is how much time to wait between retries, and we can have it in a constant time or in any exponential back-off time. We tell it how to validate if we don't get a callback from the service, how to validate the result, and also what to do in case of a failure, how to revert and how much time to try the revert, and what to do if everything failed. Like even if the revert failed, we can do something. So let's see the demo. I have the demo running on AKS, on ACA, and even locally using Docker Compose. It's the same code, just different deployment, and all the deployment scripts are in the repo. So we can choose the car class, we can choose the client, the car class, and we can ask it to reserve the car. And it's an async process spanned across multiple microservices. So we can reserve different classes. And in the inventory service, there is a limit of 2 cars. So if we look in the inventory, we see that we exhausted the number of cars. And this is why we get here a failure. So here we had a success, and we can see the different states of the Saga. And eventually we succeeded. And in the case of failure, we can see that we had a problem in the inventory, so we failed, but eventually we revert back. Okay? We can also cancel reservation, and sometimes we succeed and sometimes we fail because we fail to refund it. I will show you the code. So let's get now into the code. So using Dapper, we register 2 actors. One is for the reservation and one is for the cancellation. And when we get the API to reserve the car, we use the proxy to call the actor. This brings the actor to life the first time, and also again and again if we call it again. And in the functions inside the actor, the reserve car, we start the Saga. And when we start the Saga, this is the builder. So it gets called, it builds the Saga, and let's go to the first operation. Come on. Book a car. So we create the data, and we use Dapper to call through a queue. Can be rabbit queue, can be service bus, any queue, because it's Dapper. It's isolate the actual resource. And when we get a callback, and again, Saga ways take care also of routing the callback. So when we get a callback, we can report the outcome of the operation. And if it's false, Saga will retry the operation again. The actor will go to sleep and will be waking again in time to do the next call. Then when the Saga is completed, we report back to the client, we publish to the client the result. Let's see the other services. So this is the billing services. We can see that randomly it failed to show failure. And also the inventory service, we can see that if we pass the max allocation, we also report back a failure result. You can go to GitHub and look at the code. If you go to Saga way, you can look at the code of the demo, and also everything is open source, so you can also see the engine of Saga. It's all NuGet packages, so you can just add NuGet packages and use it. There is a text or document about the Saga pattern itself, then about the demo, and eventually even about the internals of Saga way. Okay? So let's continue. Now, using Saga is not a guarantee of success. I mean, system can be an inconsistent state. Think about, I want to cancel reservations, so I free the car. Now somebody else took the car, and now I refund, and then I find that I cannot, and I failed in the refund process. I want to reserve again the car, but the car is gone. Okay, so there is no guarantee of success, but at least you will know that you are in this state. You can do something, okay? So you can run again, you can ask a human assistant to do something, right? So the process is under control. Now, we cannot finish a lecture without saying AI, right? And we talk a lot about using AI as an orchestrator, and Saga is orchestration. So I took Saga way and I replaced the engine of Saga way with semantic kernel agent. And it's not always works. I mean, sometimes it works well and I give it like a good prompt, better than what you see in the slides. But this is an example, I don't know if it's big enough, but this is an example of the log that the agent provides about the Saga. I wouldn't go with agent right now to do Saga, and I think that even other platform like semantic kernel that is now the new process facility, they want determinism when they do this kind of workflows. But in the future, probably AI will do the orchestration, and it will use the same ideas of Saga to do the orchestration, like retries and compensate in case of failures. But probably this is the future. You can use AI for those cases that you have problems to supervise the process itself, right? So let's summarize what we saw. We moved to microservices, we raised the complexity bar. It's not single database anymore. We need to ensure that the state of the system is consistent, and it's not so easy. Think about that in any line of your code, the system can shut down. Think about scaling down the services. Actor model and the actor facility of Dapper will give you the ability to restart again, and using Saga way will load again the state and rerun those things that we need to continue on, retry the calls, or revert if there was a failure. So we will get eventually consistency. We saw Sagas and how to compensate. We talk a little bit about Dapper. You need to look more about this great framework. We saw that we can host using Azure Container Apps or AKS, Azure Kubernetes Services, or even running locally when you develop. And we saw the Saga way framework, and we finished with AI orchestration. And again, you can scan this QR code if you want to look at my book. I'm 65% in the process of writing it, and I really, really like to have feedback. Thank you very much.